Imagine holding a desktop computer in the palm of your hand that holds enough raw processing power to rival the massive, power-hungry workstation towers of just a few short years ago. We are standing on the precipice of a massive shift in the computing landscape, a moment where everything we thought we knew about desktop performance is about to be completely rewritten by a single piece of silicon. Welcome back to my channel Tech Rivet for exclusive insights into the future of tech. Subscribe my channel, hit the bell icon for more tech updates. For the past decade, Apple has been quietly building a master plan, culminating in the highly anticipated, heavily rumored, and fiercely guarded secrets surrounding the upcoming Mac Mini M5. This isn't just an incremental upgrade. It is a fundamental architectural revolution that is sending shockwaves through the entire industry. And by the end of this video, you will understand exactly why the M5 Mac Mini is the absolute pinnacle of desktop engineering. We have exclusive leaks, whispered rumors from deep within the supply chain, and hard data that paint a picture of a machine so capable, it almost feels like science fiction. You're going to want to hear every single detail of this breakdown, because what Apple is doing behind closed doors in Cupertino will change how you work, create, and interact with technology forever. To truly understand the magnitude of the upcoming M5 Mac Mini, we have to look back at the journey that brought us here, because Apple does not make random leaps. They execute calculated, multi-year strategies. When Apple first transitioned away from Intel processors and introduced the M1, the tech world was left in a state of sheer disbelief. A fanless, microscopic logic board was suddenly destroying legacy processors in benchmark tests, while sipping a fraction of the power. Since then, the M2, M3, and M4 generations have consistently pushed the envelope, refining the process, adding more GPU cores, and enhancing neural engine capabilities. But the M4, as incredible as it was a stepping stone. It introduced a brand new, ultra-compact chassis for the Mac Mini, shrinking the footprint down to an impossibly small aluminum block that mirrored the Apple TV. Many assumed that because the M4 generation brought the major design overhaul, the M5 would simply be a quiet, boring spec bump. The latest leaks absolutely shatter that assumption. The M5 generation is where the design potential of that new chassis is finally fully unleashed. What we are looking at is a machine designed from the ground up to absolutely dominate the era of artificial intelligence and high-bandwidth creative workflows, built on a manufacturing process so advanced that Apple has essentially bought out the entire global supply to keep it out of the hands of their competitors. The secret weapon powering this next-generation Mac Mini is the TSMC 3nm N3P fabrication node. If you aren't familiar with semiconductor manufacturing, a nanometer is a billionth of a meter, and the smaller the node, the more transistors you can physically pack onto a silicon die. More transistors mean more computing power, drastically higher efficiency, and significantly less heat generation. While the previous generation utilized a foundational 3nm process, the N3P variant is highly refined, allowing Apple to crank up the clock speeds and transistor density to unprecedented levels without turning the Mac Mini into a molten brick of aluminum. This thermal efficiency is the holy grail for a small form factor desktop. Inside that tiny, sleek enclosure, the M5 chip is going to run faster and cooler than anything we have ever seen, completely eliminating the thermal throttling that plagues traditional Windows Mini PCs. But it isn't just about shrinking the transistors. It is about how Apple is fundamentally rearranging the architecture of the chip itself to prioritize tasks that didn't even exist 3 years ago. Let's dive into the core architecture of the standard M5 chip, which will be the heart of the base model Mac Mini. The leaks indicate that Apple is equipping the standard M5 with a 10-core CPU and a 10-core GPU. The CPU is heavily rumored to feature a refined balance of performance cores and efficiency cores. The performance cores handle the heavy lifting, things like rendering out a 4K timeline, compiling complex code, or applying heavy filters in Photoshop. The efficiency cores handle back ground tasks, keeping the system responsive while drawing almost zero power. But what is truly blowing the minds of industry analysts is a leak regarding the instruction per clock improvements. The M5 is not just running at a higher frequency. It is completing significantly more operations within every single clock cycle. This means that even if the clock speed remained completely identical to the M4, the M5 would still feel dramatically snappier and more responsive in day-to-day use. Opening massive applications, scrubbing through dense timelines, and managing dozens of browser tabs will feel entirely frictionless, as if the computer is predicting your actions before you even make them. But if the standard M5 is a powerhouse, the M5 Pro is a completely different beast entirely, and this is where the rumors get incredibly exciting. Supply chain insiders are pointing toward a radical new philosophy in Apple's silicon design for the Pro tier, heavily focused on what is being called the Fusion architecture. For the M5 Pro, Apple is reportedly abandoning the traditional mix of standard performance and efficiency cores in favor of an 18-core architecture that introduces something completely revolutionary: supercores. The leaks suggest the M5 Pro will feature 6 of these supercores alongside 12 standard performance cores, effectively eliminating the traditional efficiency cores entirely for the Pro-level desktop chips. These supercores are designed specifically for monstrous single-threaded performance, aiming to crush tasks that cannot be split across multiple cores. Imagine you are working in a highly complex 3D environment or running a physics simulation. These tasks often bottleneck on a single core. The supercores are engineered to blast through those bottlenecks with raw, unadulterated speed. This represents a massive divergence from previous generations. Apple knows that anyone buying the M5 Pro Mac Mini is plugging it into a wall and doesn't care about battery life. They want pure, face-melting performance, and a supercore architecture is exactly how Apple plans to deliver it. The graphical capabilities of the M5 Mac Mini are equally staggering. Apple has been aggressively targeting the high-end gaming and 3D rendering markets, and the GPU architecture in the M5 generation is their most hostile takeover attempt yet. The standard M5 is expected to rock a 10-core GPU, but the M5 Pro is where the real magic happens, with options likely scaling up to a 20-core GPU. However, the core count only tells a fraction of the story. The real breakthrough is the inclusion of third-generation hardware-accelerated ray tracing and next-generation mesh shading. Ray tracing is the incredibly computationally expensive process of simulating the physical behavior of light in a digital environment, creating photorealistic shadows, reflections, and global illumination. Previously, hardware ray tracing was a feature reserved for massive, dedicated graphics card from NVIDIA or AMD that consume hundreds of watts of power. Apple has integrated this directly into the silicon die of the M5. Furthermore, the evolution of Apple's dynamic caching technology means the GPU allocates memory in real time based on the exact needs of the specific task, completely eliminating memory waste. The result is a microscopic desktop computer that can fluidly manipulate massive 3D models in Blender, render complex scenes in Cinema 4D, and handle the most demanding graphical workloads with a quiet, effortless grace that borders on the unbelievable.